Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Borczek, and this week in the news we have the following topics. The first topic is about decentralizing distribution, which is about F-Droid, which is this project here. F-Droid is an alternative Play Store for Android phones. There you can install and maintain, or the packages or the applications gets maintained, and you can just update them. It's like the regular Play Store, but for open source projects. That means you can install the open source version of Telegram, the open source version of Firefox for mobile, which is Fennec, and OpenStreetMap, OSM, and lots of other open source, Nextcloud, for example, lots of other open source projects. They actually also distribute their application via F-Droid, and the idea of this project is to decentralize the distribution. This project is sponsored by Filecoin. Filecoin is also blockchain where you provide storage space. So there you need to prove, among others, that you actually stored and provided files, and for that you get some rewards. It's actually quite huge. So if we are going to CoinMarketCap and check Filecoin, then we see it's currently rank 40. It has a market capitalization of $3 billion US, so it's a quite huge project, and they also sponsor developments that is interesting for them. And one of the project is this decentralized distribution, and there the idea is to use IPFS as a means of distribution, where the APK, the Android applications can be stored and then pulled in on in a decentralized fashion from those storage places. So this is a news. It's already was announced in February, and I just recently came across this. I think this is quite interesting, and also what they mentioned explicitly in this announcement. I thought it's kind of interesting. We are not looking at NFTs, blockchain, DAOs, smart contracts, or related aspects of Web3. So they take the grant, they want to make it distributed, which is fine, but they specifically say, okay, it's about F-Droid, it's about making it decentralized, it's about making it distributed, and they don't want to get pulled into the whole Web3 and blockchain or not discussion. This brings me to the next article, which is an article about Web3. There has been controversy about Web3. I was reporting that in the last semester. There were voices against it, for it, and in this article they summarized it quite nicely. They say, or they wrote, from it will revolutionize governments to it's a complete waste of time. So you had articles arguing it's not good, it's really bad, and there are articles it's the best thing that exists. So that's kind of a very broad topic with Web3, and yeah, F-Droid, they said we don't want to be part of the discussion. And this article is about making sense, or they try to make sense of Web3. And what I found interesting is the following sentence, what Web3 is. So they say Web3 is generally understood as a potential next generation internet based on decentralized blockchain based system, which is quite broad. So there can be lots of opinions, lots of positive opinions, lots of negative opinions. From a technical point of view, for me, Web3, it's you need Web3 to connect your browser to a specific blockchain. For me, it's a utility, it's a tool, but the discussion is about the overall, the the big picture. And from a technical side point of view, we also did and challenge tasks last semester. Most of the students also used MetaMask, which is such a Web3 bridge, and it's just a matter of, do I need it? I need to talk to the blockchain. I'm from a browser. Okay, I need a Web3 bridge. So for me, and probably for most technical people, it's just another tool in the toolbox that you can use. But for others, it's more like a philosophy. And some say, we need to decentralize everything. We need Web3. And the other part is just, okay, if you need it, use it. If you don't use it. But this is just my opinion, and here on this side they try to structure it. They have a website. For now you can add your email address, get updates. Eventually this should become some kind of a wiki-like tool where you can structure all these thoughts. Maybe that helps to make a better argument for or against Web3. Last lecture I presented Tor. It's the anonymous network where one can remain anonymous, so you don't need to reveal who you are, or you don't reveal your IP address, which can be then traced back to you. And also, if you offer service, you can use onion services, formerly known as hidden services, to remain anonymous and still offer a news site, a website. So we covered that, and in beginning of March there was an announcement of the Tor project. I was in the Tor blog where they announced that they will rewrite their current Tor implementation, which is in C, and they will replace it with a Rust-based version. I thought it's quite interesting. I quickly checked the code, so I checked out their Git repo. Their main repo has roughly 275,000 lines of code. So this would need to be converted, rewritten to Rust. For them, they mentioned it makes sense. So it's not ready yet. So this is version 0.1. But they believe that this Rust-based version is the future, so they're moving from C to Rust, which I find quite interesting. Also, second point, which I found interesting, it's funded by Zcash. Zcash is also a cryptocurrency, also one of the in the top 100. So if you go to Zcash and see where they are in rank 49, so even in the top 50, and they're funding this via their Zcash grants. So the second project I mentioned, F-Droid, which are founded by Filecoin, which makes sense because they're trying to distribute the data, so it's more like a data distribution. And here Zcash is also about anonymity. So one of the benefits of Zcash, if you do transactions, you can remain anonymous due to zero knowledge proofs. And based on that, for them, like having anonymous way to send funds makes sense to also fund Tor, which is also about anonymity. So from their alignment, it makes actually sense. There's another currency, Monero, is also privacy based. Zcash is the second famous or second cryptocurrency in terms of coin market capitalization, which focuses on privacy, where you try to hide who sent funds from what address to which other address. Then the next article, it is a guide I won't go too much into detail into that, but if you want to take a sneak peek, feel free to do so, because this will be the content of one of our upcoming lectures. So this article was written a couple of days ago, and this is a complete guide. Well, complete. Guide is never complete, but it shows how to make Docker images smaller. We will cover in the lecture what Docker images are, how to make them smaller, how to make them more efficient. Here you can read about it. Most advices are valid, and we use them as well in our company. So use a small image. There are several variations. We typically choose Alpine. You can also use Decentralized to go even smaller. Well, it's not that much smaller, but still it's quite small with all its drawbacks and advantages. You for sure need a Docker ignore because Docker for some reason scans the whole directory, and if you have a node modules in there, it just takes time. So put in a Docker ignore. And also about the layering, how Docker builds its image. It's a layer-based image. We will also cover this and some tricks how to structure your Docker file. But as I said, this will be covered in the lecture. Here's a sneak peek. You can read all about it and get a head start. The next article is also about Docker. Well, it's a Docker alternative. It's Podman. It should be a drop-in replacement, or it can be used as a drop-in replacement for Docker. I tried it at some point. Some things did work, some things did not work, especially when sending then the images to registry that was created by Podman was not really able to make this image run. So there are still a couple of minor issues, but it's thought as to be a replacement of Docker. And they even go a bit further. So what they are proposing in this blog, or they actually improve their software in order to copy images more easily from one machine to the other. If you use Docker, you have to do it a bit differently. Here it's just one command line, Docker, Podman, SCP, and then say image from this machine to that machine. If you want to do it with Docker, it also works, but it takes you a bit more work because you need first to save the image to a tar file, then you need to SCP the tar file to that remote machine, and then you need to call again Docker load and load this tar file into the local registry, which also works, but yeah, they're making an effort to simplify this step, which is for sure nice, but this makes it also incompatible. So once you adopt Podman and use Podman SCP, it's difficult to go back from Podman to Docker unless Docker also comes up with the same feature as Podman. The next article, also highly relevant, also to the lecture that I did yesterday, basically in this week. So I was talking about protocols, the second part, and there I also mentioned congestion control, which also has an influence on the performance, or can have an influence on the performance. So this article, which was written beginning of March, talks about their change from the cubic congestion control mechanism to BBR. And just as a reminder, I'm using Linux, and the default implementation of Linux is actually cubic as a congestion control. So probably if you install Linux, you will have the same congestion control, and this works okay. It can have some problems, especially if the network is congested, because the cubic mechanism reacts if there is a package, a packet that is dropped. So whenever you send data, there is a packet that is dropped, so there won't be an acknowledgement that will be notified, or the sender will get aware of that and then starts sending less data, so to reduce the traffic so that the package won't get dropped the next time. The problem is that in between the path from sending the packet, there are machines that have buffers, and the buffers can be quite large. So your packet might get into a buffer. So if the buffer gets filled and then you don't have any more room in the buffer, the packet gets dropped, then Cubic will be Cubic knows, hey, there was a packet that is lost, so I need to send less data. But the problem is if if the packet is still in the queue, there's lots of data in the network, but eventually the congestion will disappear. So the packet might get might get transferred at the later stage, so it will be in a buffer, and once the buffer empties, the packet can be sent. That means that the packet will arrive, but a bit too late maybe. So this increases the latency. And the idea of BBR, I also have here a link of all the congestion control algorithms. This site here. For example, Windows typically use compound TCP, and they now used BBR, which came initially from Google, and it's about bottleneck bandwidth and round trip propagation time. So that means this mechanism is not relying on if a packet gets dropped, but also measures the time from sending to receiving. And if you see, hey, this packet had an unusual large time to reach from source to destination, because I know in the past when I sent data to this destination, it has a certain round trip time, which is, I don't know, like 100 milliseconds. And if I now measure it takes 150, then I know, okay, something is not right. Maybe there is a packet somewhere in a buffer. So I already try at this point, when I realize that the latency gets higher, that the sender will send less data to not overload the traffic. So to be aware at the early stage that, hey, there might be a congestion, I will send less data. And by changing from the Cubic to BBR, they measured in this site that they had quite some significant performance gains, up to 21%. So they did some nice measurements. So here is if you have a really good connection, it doesn't actually matter that much if you use Cubic or BBR. So they measure 2 to 6% improvement, which is still nice. But if you have poor connections, meaning you have packet drops or you have packets in queues, then they measured on a performance increase of up to 21%. And I think this is quite significant. So yeah, that just to mention that the topics we cover in this lecture, they are bleeding edge and highly relevant also for the performance of the web, the performance of the internet, and eventually if you build a service on top of a given network stack, then it has also an impact on your service. Another interesting point they mentioned is that when switching to BBR from Cubic, they measured that some autonomous system, they actually do the packet forwarding. The packet forwarding with BBR is actually worse, but just for this autonomous system. Somehow, I don't know which AS it was, which autonomous system it was, but that's kind of also interesting to see that there are specific autonomous systems which have also most likely optimized their performance to a certain congestion algorithm, because they were constantly worse using BBR than Cubic. And the last article is about cryptocurrencies. It's about USD Tether, which I thought it's quite interesting. It's about a hedge fund that is or that shorted the USD Tether. That means they think that Tether in the future will have less value. So they want to make profit when this token value gets will become lower. The point is that USDT or Tether, which is a stable coin, so this is pegged to the US dollar. So if you go to CoinMarketCap, we see that one. We go back here. We see that no. Back here, we see that one Tether is actually always $1. There are other stable coins like USDC. Oh, sorry, this is USDT. USDC. This is USDT. Also, there are other stable coins. There is the Terra USDT. So here we see that the value or the exchange rate to a dollar is always 1. That means it's a stable coin. And the interesting thing is that the USDT, they claiming that their coin is backed by a stable currency. Sorry, this link here. So they have backed their assets, and around 24 billion of those 80 billion, so they have a coin market cap of 80 billion, so they need to back this 80 billion with real USD dollars or any kind of assets which can be easily converted to US dollars. And 24 billion out of those 80 billion they have in so-called high yield assets. And those high yield assets, there's speculation now that those high yield assets are assets from Chinese real estate markets, and those are currently not in a good shape. So this company is betting that this Chinese real estate market is going down, or will go down in the next few months, or in the next half year or until a year. And if this 24 billion then if this asset is not or loses the value, then it can be that the USDT is not fully backed anymore. That means if people withdraw the money from USDT, they would not be able to provide the actual value, and it would have a shift in the exchange rate. So the exchange rate would go down because more people want to sell their USDT, and yeah, that's what they're speculating. It's highly speculative. So anything I say in the news and also in the lecture, I'm involved in a couple of crypto projects. So don't take anything as an investment advice. Don't short now on USDT unless you're willing to throw that money out of the window. Anything I say, it's not an investment advice.